And finally, we have translations. State the vertical shift, amplitude, period, and phase shift of each function. Then graph the function. So lots of things happening here. We'll just go one at a time. The vertical shift is going to be the number that is outside of the grouping symbols, which is right there, and that is -3. So we have a vertical shift of -3. So actually I should say it goes down 3 units. And let's see, the amplitude is the next thing it's asking for. The amplitude is 1/2 for that 1/2 right there. The period, so since it is a tangent function, the period is going to be 180 divided by the b value. The b value is right here. It's that 2 right there. So 180 divided by 2 gives us a period of 90. And then the phase shift, which is the horizontal shift. The phase shift is right there. So we have a 30 degrees phase shift to the right. So we will say right 30, even though it is a -30. -30 means right 30. So that's going to be what we're going to graph for the final answer. But we will first start out by graphing the parent function, which will just be y equals 1/2 tangent of 2 theta. And that does not include the parts of the graph that includes the shifting, which is the -3 and the -30. So we graph y 1/2 tangent of 2 theta. So that graph is going to have an amplitude, or excuse me, an a value of 1/2. The period is still going to be 90 degrees. And we use that graph to figure out where the asymptotes lie. So the asymptotes will be lying at 180 divided by 2 times b. So 2 times 2, which is 45. So just like this graph up here, it's going to have the same asymptotes. That, again, that's for the parent function. So we will be at -45. And as I'm drawing this in, notice that I went by 30s this time. The reason I went by 30s this time is that because there is a horizontal shift of 30 degrees, it made the most sense to make each block equal to 30 by going by 30s. At least the most sense to me. Okay, so then we have to do our shift. So it is down 3 and right 30. So down 3 means I'm going to take my midline, the x-axis, I'm going to move it down 3 units. And then I'm going to go right 30. And that means every one of those asymptotes is also going to get it moved right 30. So to move those asymptotes right 30, I'm going to start with the one on the right. And remember, each block equals 30. So right 30, so that asymptote in red right next to it is now that asymptote in blue. And in order to keep this from being a total complete mess, I'm going to go ahead and erase that asymptote right there. And then I'll move the next one over 30 degrees. And then I'm going to erase this asymptote that it was related to. And then the next one gets moved over 30 degrees. And so on. And hopefully by doing it this way, you can see where the final graph is going to be. And it's going to be hard to erase that one without erasing all my numbers, so that's pretty good. And then we will graph through the midline. So here's the middle point of the midline, here, here, and here, and we draw our S shapes through there. And there's that tangent function. 46, y equals 1/2 cosine the quantity of 1/4 times theta plus pi over 4 minus 1. So a lot to uncover there. We'll just start with the amplitude. The amplitude is 1/2. the period, it is cosine, so it's going to be based upon 360. So that's going to be 360 divided by 1/4. However, notice that since we are in terms of pi, pi over 4 is what it gives us one of the shifts in. So instead of saying 360, we're going to use 2 pi instead, because pi equals 180, so 2 pi equals 360. So 2 pi divided by 1/4 is 8 pi. So I've got it numbered in terms of 2 pi for every 4 blocks. That means every 2 blocks is 1 pi. The vertical shift is right here. That is going to be down 1 unit. And the plus pi over 4 is our phase shift or our horizontal shift. That means we're going to the left pi over 4 units when it's time to do our shift. So that's all the information we need for our shifting. So before we do that, we will graph the parent function of y equals 1/2 cosine of 1/4 theta. So everything except the shift. So 1/2 cosine 1/4 theta will have the same period as the shifted function will of 8 pi. Being cosine, it will start at the high point, which is only going to be a half a unit high. And at 8 pi will also be at a half a unit. At 4 pi will be at its low point, which is only negative half unit. And then at 2 pi, which is halfway between 0 and 4 pi, will be on the x-axis, the same for 6 pi. So this is one full period of the unshifted graph. If I want to complete that, at 10 pi, it'll be back down on the x-axis. At 2 pi, we'll be back at the x-axis at its low point at negative 4 pi. And then to shift it, we will first do the midline. The midline will be shifted down 1 unit. So I will draw a blue dotted line to represent the midline of the shifted graph down 1 unit. So every point will be shifted down 1 unit. And we also have to shift left pi over 4. Now let's consider this. If 4 blocks is 2 pi, then 1 block is going to be pi. 2 blocks will be pi. 1 block will be pi over 2, or half pi. And so half of a block is going to be pi over 4. So to shift to the left pi over 4 units is only going to be a half of a block shift on the scale that I'm using right now. So every one of those red key points, I'm going to move down 2 blocks for 1 unit and then left half of a block. So from here down 2 blocks, half of a block. So from the negative 2 pi red point goes down 2 and to the left 1. The one that's on the y-axis will go down 2 to the left half of a unit. Down 2, left half of a unit. Remember, I'm going down 2 blocks because each 2 blocks represents 1 full unit on the scale that I have chosen. Half of a block is pi over 4 to the left on the scale that I have chosen. So here is the final graph. Draw my roller coaster hills right through there.